Fun with Farm, Inflammation Mini Lecture 204, Eicosanoids. In addition to their role in maintaining cell membrane integrity and fluidity, membrane phospholipids serve as substrates for enzymes. The products formed are often autocoids, substances that produce brief effects locally in the tissue where they're formed. Phospholipase A2 cleaves the phospholipid at the SN2 position. The type of fatty acid at this location, omega-3 versus omega-6, will determine the general net effect of the end product. When the SN2 position of the lipid membrane is occupied by omega-3 derivatives like eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, the products formed are anti-inflammatory. These products are considered to protect against cardiovascular disease. Omega-6 fatty acids like linoleic acid, the end products tend to be pro-inflammatory. Linoleic acid and alpha-linolenic acid, ALA, are essential fatty acids that can't be synthesized by the human body. While ALA is an omega-3 acid, it's probably not as potent at protective effects as the longer-chain omega-3s. Phospholipase isoenzymes are classified according to their site of action on phospholipid substrate molecule. Phospholipase A1, PLA1, cuts off a fatty acid chain of a diacylphospholipid in the SN1 position, while phospholipase 2 attacks a fatty acid chain which is at the SN2 position. Phospholipase B, not shown in the diagram, can cut off both fatty acid chains of a diacylphospholipid. Phospholipase C cuts off the head group of a phospholipid. Phospholipase C action generates IP3 and DAG to increase intracellular calcium. The GQ-coupled protein receptors activate PLC. Phospholipase D is really cool. It cuts off the polar head of a group of the phospholipid, generating lipids that signal in our endocannabinoid system, our endogenous cannabis-like system. In the scheme on the slide, R1 and R2 are two fatty acid chains, and polar head depicts a variable part of the head group of a phospholipid molecule, while R3 is a fatty acid attached to the polar head. Calcium-dependent phospholipase A2 catalyzes the first step in the generation of inflammatory prostaglandins and leukotrienes and the anti-inflammatory lipoxins. Leukotrienes were formerly known as a slow-reacting substance of anaphylaxis. After the SN2 fatty acid is cleaved, other enzymes catalyze the formation of the ultimate products. There are at least two isoforms of cyclooxygenase, also known as prostaglandin H synthase. Cyclooxygenase 1, or COX-1, is constitutively expressed for the formation of housekeeping products. For example, in the proximal duodenum, PGE2 increases bicarb secretion, while cyclooxygenase 2, or COX-2, is mostly but not entirely induced to produce mediators of inflammation upon demand. End products formed from COX catalysis are determined by the specific synthases in the specific tissues. End products may include the prostaglandins, prostacyclin, also known as PGI2, and thromboxanes. Note that LOX and COX compete for the substrates released by PLA2, usually arachidonic acid. The lipooxygenase pathway is responsible for the formations of leukotrienes and lipoxin. Leukotrienes, once known as a slow-reacting substance of anaphylaxis, cause pretty profound bronchoconstriction, white blood cell infiltration, and mast cell degranulation. There's four common pharmacologic targets of significance that decrease leukotriene synthesis or activity, three of which are the mechanisms of FDA-approved drugs. First, we have our cystenyl leukotriene receptor antagonists like montelukast or Singulair. Then we have our 5-lipooxygenase inhibitors like Xylutin. Phospholipase A2 inhibitors include the corticosteroids. They inhibit PLA2 as part of their mechanism. Currently under investigation, we have inhibition of 5-LOX activating protein, or FLAP. No drugs are currently on the market in that class. Cystenyl leukotrienes are associated with allergy and asthma, leading to inflammation, airway edema, and bronchoconstriction. Xylutin is a 5-lipooxygenase inhibitor that inhibits 5-lipooxygenase to inhibit leukotriene A formation, which will block formation of downstream leukotrienes, while montelukast and zafirlukast block the cystenyl leukotriene 1 receptor to decrease bronchiolar constriction, leukocyte activation, and secretion of mucus. Decreasing leukotriene activity decreases edema of the airway and bronchoconstriction, so what conditions do you think they're used to treat? As we said, asthma and allergies. Which class or mechanism of action do you think produces the fewest side effects, blocking lipoxygenase or inhibiting the receptor? Well, inhibiting the receptor is a much more selective action, so montelukast produces fewer side effects than Xylutin. When the SN2 position is occupied by an omega-6 fatty acid, cyclooxygenase 1 or 2 will catalyze a reaction to form PGH2. The synthase in the tissue where the PGH2 is formed will catalyze the next step to produce inflammatory products. In platelets, thromboxane synthase catalyzes the formation of thromboxane A2 to promote platelet activation. In platelets, it's COX-1 that forms the PGH2. Aspirin inhibits COX-1 for the life of the platelet. When the SN2 position of the membrane phospholipid is occupied by an omega-3 fatty acid to release EPA, the products formed are actually anti-inflammatory. Thromboxane A3 inhibits platelet aggregation. When that SN2 position is occupied by an omega-3 fatty acid, we get products that include the resolvins, the protectins, and the merisins. These products, among other things, promote resolution of inflammation, they inhibit osteoclast uptake of bone, and they can help protect tissues from reperfusion injuries after ischemic events. Not all omega-3s are created equally. Omega-3s from vegetable sources require a three-step conversion to form EPA. Diets rich in animal fat inhibit this conversion. Fish is high in EPA and DHA, as is venison. Dietary manipulation can have an impact on inflammation. Increasing omega-3s by eating more cold water fish, decreasing omega-6s by eating less red meat, will decrease the omega-6 to omega-3 ratio. This is going to increase the formation of those 3 series prostaglandins, which can have an anti-inflammatory effect. This may produce a benefit in cardiovascular disease. Another important fatty acid-derived product is platelet activating factor. Like other eicosanoids, it's synthesized upon demand. The receptors for platelet activating factor are GQ and GI-coupled protein receptors. These receptors activate a cascade of events that leads to the formation of the primary platelet clot. Additionally, platelet activating factor increases the activity of phospholipase A2, phospholipase C, protein kinase C, low-density lipoprotein receptors, and transforming growth factor beta, which is a primary switch for activation of fibroblasts leading to fibrosis. Fatty acid signaling plays a key role in the inflammation that underlies cardiovascular disease. To make it even more complicated, the endocannabinoid system is part of this whole scheme. Anandamide and 2-arachidonoglycerol are endogenous native feedback controls that, through our cannabinoid 1 receptors, prevent excessive activation of excitotoxic, potentially inflammatory pathways, often gated by glutamate NMDA receptors. Our CB2 receptor activation on immune cells activates multiple pathways to modulate inflammation.